When you're doing forces in equilibrium, one technique for finding out missing forces is Polygon of Forces. So if we have a static system, so we have a point, and on this point here we have three forces acting. And let us make this force, I don't know, 100 newtons, just a nice round number. This we're going to make at right angles, this we're going to make at 135 degrees. And this one also at 135 degrees. I know the size of this force, I want to find out the size of these two forces. And we'll apply this in a second in an example. So if I know this force is 100 newtons, 100, and what I can do here is I can apply this force. So this force goes out this way. I've set this up intentionally so it's right angles, so it doesn't have to be. And I know this force comes back at 135. So if this is 100 newtons, this is going to be, I call that 1, this is going to be 2, this is going to be 3. So this is 1, 2, 3. We know this angle here. This angle is going to be 45 degrees. Well, so that's 135, so this is going to be 45 degrees. So the question is, how can I figure out the size of these? And the answer is, we know triangles very well, so we're just going to use trigonometry. So if this is a right angle triangle, I know this is 45, I know this is 45. So I can then use, if I know this side, I want to find that side too, I can just use tan, because there's the, if I'm using this angle, doesn't matter that angle, if I'm using this angle, that's the opposite, that's the adjacent, so tan theta equals opposite over adjacent, the opposite equals adjacent tan theta, which is equal to 100 newtons, tan 45 degrees, which is going to equal 100 newtons. So this side is also 100 newtons. So I'll now know this is 100 newtons, that's it. And then I can work out the side here. Well, in this case it's a right angle triangle, so I've got plenty of ways of doing this. I can use either, I can use Pythagoras, or I can just use Kata again. So let's use, if I'm using this angle, I want to know this one, I have that one, so cos theta equals adjacent over hypotenuse. So I want to find out the hypotenuse. Hypotenuse equals A over cos theta, which is equal to 100 newtons over cos 45 degrees is equal to 141.2 newtons. So I can work out this one is going to be 141.2 newtons. So I therefore know this is going to be 141.2 newtons that way. So now I know all the forces. This, okay, later on you can then do this totally analytically by just working out all the components and doing it this way, but I like to do it this way because I know triangles. I can do triangles very, 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 very well. So let's do another, I'll do an example in a second, but as I said, with this technique you can work out up to 2 unknown things, and that's what we did here. We knew one size, we could work out the other two by